So here we go, Pi to Arduino serial USB. Now, if you saw my previous video, you'll know that I configured a Linux PC, which is my main PC that I'm recording this on, using Linux Mint desktop and so on, to connect via USB to an Arduino. And then using the serial connection, purely using the serial connection and command line, I was able to transfer a Arduino sketch. An Arduino sketch is basically a small C program, and you compile it on the well, if you're looking at this picture, then you would compile it on the Raspberry Pi, and then you would transfer it via the USB cable onto the Arduino Uno or similar, various Arduino models, obviously. So if you've got a Nano or whatever, it doesn't make any difference, still the same concept. So what's the point of this? What's the point of anything? Good question. By doing this, what you can do is, say for instance, you had a very dirty, dusty, noisy, dangerous factory, and you were controlling. Now, just because this is an Arduino and you can buy it for sort of home projects and make little toy robots with it, that's fine. But this is a microprocessor, so instead of this, you could have any kind of microprocessor, and the whole point here is that you can communicate with it via serial, via USB, over SSH, and by doing that, you can have Pi or similar high up in a factory, right? Cable tied to some metal beams with a little 1.8 meter USB lead, which then connects into the microprocessor. It saves you having to stand on a pair of steps right next to a big saw blade spinning at 5,000 RPM, about to chop your leg off. It saves you having to do that and connect with a USB cable into the microprocessor. For instance, should you need to upgrade the control software. Now, a lot of the time, once it's working forever, but obviously sometimes you may need to do upgrades and you might want to alter the code. So instead of standing on some steps, holding a laptop in one hand and holding on and typing with the other hand, which I've done many, many times, without high vis, without safety boots, without goggles, been there, done it. So, yeah, just to get back, right, what you need is obviously to connect between Pi and the Arduino, you need a to B USB cable. I couldn't remember what it was called. A, B, C, whatever. So the 24AWG is just thickness of the wire. That's not too critical. So the objective of this project, which I'm kind of introducing you to today, this will be part one. There will be more parts to it. If you ever watched my early videos where I created a 2-axis, borderline 3-axis CNC machine out of motors and wood and slide rails and so on, what I would ultimately have done there would to have been to have taken out the Raspberry Pi, put it somewhere in a little enclosed box, somewhere safe, and then ran the USB cable to an Arduino, which was then next to all the motors and would have then had the Arduino controlling the motors. So the objective is to SSH using kind of, if you're on Windows, then you'd be using PuTTY. If you're on Mac or Linux, you would just type SSH in terminal. So then the idea is to edit or create, compile, upload code to the Arduino, or via the command line, so no GUI interfaces involved at all. Ultimately, write native C code for Arduino and automate the entire process with Python. So there's quite a few things going on here. if you're here for the Python bits, there won't be any Python today, but let me just describe the whole purpose. All of this is several steps. So SSH to the Pi is one. Then what would you do? You'd open a text editor, you'd write some code or drop in some code if you're automating it. Compile, which you saw in the last video. Upload, you saw in the last video. And all these steps you could actually script. So say for instance you wanted to write some code or write a script that would some days you wanted the machine to have a 1 second pause between sewing up bits of word, and the next day you wanted a 2 second pause because the bits of wood were longer. You might want to just do it all manually, fine, but with this you could have a variable in your Python script. That could then drop the variable into the string, and then the whole string would then be saved as a .ino file, and that then lives in the Arduino directory, and then you run the compiler using the you'd pass the file name as a variable, then you would paste it. You could actually run all this from Jupyter Notebook if you really wanted. What you would do would be you'd run Jupyter Notebook on the Pi, which would then generate the link, and then that link you could click on, and then you could do all this from the browser on a remote machine. Anyway, I think we're getting ahead of ourselves here, so let's just open up. Let's make that go away now. So what I'm going to do is just to give you some more background here. I've got some links here. So I was going to do a fritzing diagram, but it seems they're temporarily down for maintenance, which is a shame. So yeah, that's the cable, £1 and 2p. I'm guessing the 2p is because of inflation. Anyway, so Arduino, this was if you saw the last video, this is what I used. So shame on me, but unfortunately due to financial restraints, I'm using an unofficial unknown Chinese Arduino board. And this is the really good link that absolutely helped me. So I covered all this in the previous video, so I'll put the link down below. You can go and have a look at that. That was to actually just enable me to compile and upload via the command line. So go and check the previous video for that. What I want to just cover quickly now is how, or just quickly give an overview of setting up the Raspberry Pi so that you can remotely SSH to it. So fire on Raspberry Pi, there we go. So you can come in here and you can do it through raspi config. And then if you want to you can then go back in and set up a static IP address, which I'd really recommend. You can probably set up a host name and then access it via that, but I just find IP addresses are a lot more reliable. So there we go. It's all on raspberrypi.com documentation. So I'm not going to cover that here, but setting up a headless Raspberry Pi, there we go. And you have to create a file called wpa_supplicant.conf. You have to choose a region. If you're in the UK, I scrolled all the way down the United Kingdom, and then I realised I had to go back up to GB, which was annoying. That's something to do with ISO AEC, so it's probably not Raspberry Pi's fault before anyone gets offended. Yeah, so you need to know what range your home network is on, which is, you can just type in, you can type in 3 letters. Go to command line, type in IP space A. Then you just need to, I think it's set through a DHCP, there we go. That's the file where you go in and you can set up a static IP address. I did a Raspberry Pi video on that several years ago, so it's still the same. The interface, if you're doing it over your Wi-Fi, the wireless LAN interface, if you've only got one, you've not got anything else, any secondary USB wireless LAN controller, USB thing stuck in the side, then typically it will be WLAN 0. So yeah, it's all here, raspberrypi.com. So what I might do now is actually, I forgot to turn it on, so just bear with me, and I'm just going to power on my Pi. It's just out of sight. Sorry about this. Be with you in a second. There we go. Switching on. I don't know if you can see this. Let me just there we go. There's the Pi, and there is the Arduino. To be honest, I don't really need to keep showing it to you. We'll SSH into it in a second, and then hopefully you will know what a flashing LED looks like on the Pi, or not on the Arduino. Right, so let's have to wait for it to boot up, and then we will SSH into the Pi. We'll have a look around, and then what we'll do is we'll go and have a look at preparing to, or we'll look at the difference between writing native C code and, actually I'll just check, am I still in the picture? Yeah. We'll have a look at the difference between writing native C code and writing code for the Arduino. Some of it is CP. CP. We don't want C++. There's no need. So here we go. So this is probably what we're going to be looking at, or what I'm going to be looking at in the next week or so when I get time. And board components. Yeah. So that's talking about the pins. So that's the Arduino editor, which we're actually going to eliminate, and blinking an LED. Okay, so when they say C, they actually are just doing it with the Arduino editor. Right, so what we look at is natively programming Arduino. And Arduino versus native language. Here we go. So I think this is what I will need to be doing. There's a couple of little bits. You need to set the port using, so what I want to know is whether the Arduino code takes more space with or without the Arduino library. Here we go. Why stop there? You can get even more minimal. For example, you learn that you can toggle a pin by writing corresponding bit in the input register when it is configured for output mode. Also, you don't really have to return a value in main, so we can just do int main void ddrb ox20. So that's pin 13. And then toggle it here. So that's toggling it. And yeah, you save lots of memory by not using the Arduino clock interrupt system, but you also lose minis and micros, which can be incredibly convenient. That's the thing about how Arduino system was built. You have options. You can do it any way you want. You can program the thing in assembly language or even straight up hex if you want. You can save even more space if you never enable interrupts, so you don't have to include an interrupt vector table. It's all about which API you want to use. You choose one that gives you the amount of control you want while not making you create the entire system for yourself. So here's a good link, or a good book on the subject. You're using direct port manipulation, Arduino internals. $59. No, I can't afford that. So we've kind of established that you can program natively in C. So first thing first is SSH. So I was actually going to set this machine up as an umbral. So 192.168.1.9 is the Wi-Fi static IP address, and this is quite an obscene password, so I'd better just type this quickly. There we go. So we're now on the Pi. There we go, IPA, and there we go, WLAN 0. And obviously we had the right IP address because I'm on it. One thing I had to do on this was export path. I installed the Arduino CLI binary, but you have to go into, let me just show you that as well. So let's do Control L clear, and then vim /basrhrc. There we go, so it's on that line still. Do you see the flashing cursor at the bottom? So I had to export path, so home/bin, and then send it the path. Excuse me. Because where I'd actually put, yeah, so if I think I put the Arduino binary, I think I put the Arduino binary in there. Yeah, there we go. So if we go and just to show that it actually, just to check it's installed and available, we just do Arduino CLI, and there we go. And then we get all the options. So bed, bin, bootloader, cache, compile, completion, core, daemon, debug, help, lib, monitor, outdated, sketch, update, upgrade, upload version. Okay, so yeah, I found out what the problem was with Jupyter Notebook running it via the Raspberry Pi. So what I did was found this on Stack Overflow, and I think I've done it before, I just forgot. So you need to go into, let me just show you. So let me close it, shut down the server. Yep. And the file I had to edit, so I installed Jupyter Notebook, and then I had to edit this file. So Jupyter _notebook_config.py, and these are the lines you need to add. So those lines, thus you can enable a password as well, which I should probably do, and you can tell it to listen on all IPs. Depends how far away your neighbors are. No, seriously, because otherwise they could actually access it if they knew the link. So yeah, just add those lines in. Those lines are not there; they're not even commented out, so you will need to add those in. I'll leave that up there for you if you need to copy. So it's open browser, port, allow remote access, allow origin, and then listen on all IPs. So there we go. I'm going to close that now. Hopefully you can pause that if you need to. So then when you run Jupyter Notebook, I'm on it's called Umbral, this Raspberry Pi, but rest assured it is a Raspberry Pi. In In fact, how do I show you if it's a Raspberry Pi? Is it, it's uname, isn't it, on Linux? Uname. Is there a switch as well? -v? No, it's not, is it? I always do uname, but that's only because I need to. What is it? Let me find. Linux show system info. It's probably not the right thing to search for, but it will get me there. Uname, that's what I did. Uname -v is what I did. Oh, uname -a, isn't it? So. Well, it's actually not called itself a Raspberry Pi, but Arch 64 GNU Linux. Well, let's do try this one. Sudo ls hardware. Oh, that's not installed. Probably got to install that. Another one. ls show. ls CPU, of course. There we go. It doesn't actually show us a Raspberry Pi because I've installed Umbrel. Umbrel, if you're interested, is an operating system which is specifically made to run a Bitcoin full node. Anyway, I digress. So yeah, if you want to run yeah, so Jupyter Notebook. In fact, is that still, will that link still work? Let me try. Yeah, I think so. Yeah. So now I'm running my Raspberry Pi as a Jupyter Notebook server. And the whole point of this, I can move that now, is if you don't already know, you can run. That's not good, is it? The text box is smaller than the. Okay, let's just do that for now. You can run Linux commands within Jupyter Notebook, so it's not strictly just for Python. And there you go, you can see the directory of my Umbrel, which is my Raspberry Pi. And then we can actually run the Arduino compile, the Arduino upload commands from Jupyter Notebook, which I think would be quite nice. What we'll then do is put the native C code into a string. So if we let's cd to other. It's because I didn't run it all in the same window. Let me merge those. So I'll run all. Perhaps I've got to run those in a chain. Does that work? Soon find out. There we go. And then you can see my blink to directory, which is the folder which Arduino looks for when you pass it the commands to actually do some uploads or some sort of compiling. So I could actually run that now. Let's run compile. in Jupyter Notebook. I'm on the wrong workspace, possibly. There we go. So now, if I do exclamation mark and then that command, I don't know why the text box is I'm using the Brave browser. I'll go back and try another browser in due course. And that should compile. Why is it? I know, I need to go into the Blink directory. So if I do Blink 2, run it again, it should work. There we go. See no valid sketch found in umbral missing home. It's looking for umbral.ino. I know that all needs to be the same. That all needs to be the same line, doesn't it? So instead of ls, let's paste that in there. Remove this. Sorry, we'll get there in a second. Just bear with. So it's switching to the Blink2 directory, and then there's compile, and there we see we have using Jupyter, which is basically Python. It's a Python editor notebook. Don't need to tell you what Jupyter Notebook is. So from Jupyter Notebook, I've run a command, a Linux command inside Jupyter Notebook, which has then gone off and compiled my sketch. And all of this is happening on the Raspberry Pi, but as you may or may not see, you can see the Linux Mint in the bottom left corner. So I'm on my laptop, which is SSH to my Raspberry Pi, which then is talking to, so in actual fact, as well as doing that, I could then do, I could actually do that as well. If I put double ampersands, and then I could put in the CLI upload. So then I could upload my sketch to the Arduino as well. So let's do that just for lols. Yeah, sorry, it's gone off the edge of the screen, but for now that's all right. So what it's doing is it's compiling the sketch, and hopefully it's flashing it. Yeah, I think it's done it. No complaints. So anyway, that's the setup for this project. And in the next part of next video, we'll actually get on and do something, start writing some code. So yeah, thanks for watching, and see you again soon.